Batul is not here.
I'm asking her 1 second.
Okay, please tell her to join.
I'm sorry, I wasn't able to answer.
Okay, it's fine. Yala, you can continue and
Yeah,
you
we
can
were
continue.
yeah we were only concluding how
Okay.
and how hybrid power systems can actually offer solutions that individual technologies alone cannot match on their own. يعني إذا we implemented power PV alone or wind alone, they wouldn't be effective as integrating it in a hybrid power system. And they are a good way of having available sources of energy, which optimizes the utilization of primary energy sources, and it offer market energy for technologies because like installation, as Ellen said, of PV alone or wind alone would be really very costly. That's why when it comes in an effective and optimal system, hybrid system, it would allow for their entry in the market. Thus, we can hit two birds in one stone, achieve energy security and protect the climate change. And finally, this technology has to be explored, enhanced, and invested for achieving energy security, allocating properly the resources, the limited and scarce resources that we have on the planet, for obtaining economic growth and contributing to a sustainable environment. Last but not least, we want to point out in a small thing, which the motto that we were using through the whole presentation, and it was written at the bottom of every slide, but I'm not sure if you all realized it. It's that the whole is greater than the sum of its parts, and that's exactly the takeaway from our presentation, is that the whole is greater than the sum of its part. We may get energy from each and every source, but it wouldn't be as effective as combining it all in one plant. And thank you a lot.
Okay, thank you so much. Any questions from students? Okay, so I want to ask you if you want to suggest a system to use in Lebanon. Okay, what will you suggest? I will start with Batul.
Yes. So basically, on the short run, I would suggest to use a solar diesel system only, because the wind system, for it to be implemented in the first, it needs a lot of infrastructure to happen and delivery systems, and thus it would be hard to implement it at this very early stage. And we are now sinking in economy, and as Ellen mentioned, the cost of implementation usually is higher at the beginning, and then it decreases with time. So we are not ready to invest this very large, this very huge amount on the wind energy, while it's effective, its efficiency is not as high as the solar one. Thus, I would suggest to start to implement the solar and a solar diesel combination, and for later on, definitely we can include the wind. We have potential areas as in Akkar or so, but as I said, they need infrastructure that we're not ready to have, that we don't have in the first place, and that we're not ready to make.
Okay, thank you. Now, Ellen, concerning the economical studies done, do you have an idea which systems and calculations were used for the economical analysis? So did they take into account risks in future?
So in the paper we found was made by the Ministry of Energy Energy and Water. So it was a brief report, like the conclusive study. So they didn't really mention those actually.
Okay.
Yes, Henry, they mentioned capex and registration capex, I think, yeah.
Okay. Can you go, please?
They used financial indicators, payback period and PV bus. Yes, sorry.
Yes, and operation and management.
Okay. Can you go up a little bit with the slides, please? So I think it was maybe slide 30. I think بال30 can.
30.
Can you go over them and I will tell you which one? Okay, yes.
Okay, fine.
Ellen, can you please give some details about what is happening here?
Sorry في lag and the slides at 30.
هلا وقفتوا على السلايد. No,
Yes,
مش
30.
هذا اللي وقفتوا
30
عليه،
يعني.
اللي وقفتوا عليه وقلت لك stop here.
أو في lag يعني.
إيه
هيدا. This one.
Okay, so this is a PV, the three together. So on the left, we have the ones they produce AC current. We converted to DC inverters. We also have the PV arrays, which have DC energy. They converge to the same DC line, and some of the energy and the energy goes to the ATS controller automatic يعني, to be taken back to the load and to the main grid into AC form. However, when we have shortage in one of them, we need to provide electricity to the demand from the B, which have been previously charged with who have previously been charged wind and PV. So it goes back to the load, and the battery discharge is fully discharged. Then we will have also to turn on the diesel generator, which produces AC. It should be converted back to DC, so everything at the controller area. And then at the controller, it distributes it to load and grid. Okay, but in deficit time, I talk about deficit time.
It's fine. Thank you, Ella. Thank you. Okay, thank you, guys.
Okay.
Bye.
Thank you, Professor.
Thank you, Doctor.
Well